add-in for Revit. And they'll be talking about the work that they've done in their offices. So Dan Howard at Ballinger and Mitev from KieranTimberlake. And they're a part of a Dynamo user group, right, in the city. That kind of a growing group, and Dynamo is kind of growing momentum in practice. And they're sharing kind of and collecting their own work in this group and have been gracious enough to share a lot of what they're doing in their offices with you. And the goal of the lecture is to introduce you to the possibilities of Dynamo and to really kind of get you excited about what you might possibly use it for, either in your own academic kind of design setting or even in practice taking things back to your own offices. So yeah, so thank you guys very much for taking an hour out of your night and a lot of hours, I'm sure, getting stuff ready for us. So thank you. And thank you guys for coming.
Yeah, thank you.
All right. Sure. So, yeah, like Jackie said, what we're going to try to do tonight is really just give you a broad overview of our experience and some of the examples that we've seen. We're going to touch on just what some of the basic concepts are in Dynamo and with programming, and not go into too much detail on any one thing. We're happy to go into as much detail as you'd like if you want to ask questions afterwards. But we're just going to try to give a broad overview and not so much of a tutorial. So my name is Dan Howard. I'm a registered architect. I work at Ballinger. I've been there for about 12 years. I've been using Revit for probably 11 years. And I'm actually fairly new to Dynamo. I dipped my toes in it a few years ago, and then got busy with other things and came back to it about a year ago and really have been diving in. And the Philadelphia Dynamo user group that Peter helped found has really been a great resource for me. So that has been my experience in it. I teach in the interiors department here, teaching some basic Revit work. And yeah.
Yeah, and I am Peter. I did a double header of degrees in Cincinnati way back when. I am the BIM specialist at KieranTimberlake, and I did found the Philadelphia Dynamo user group along with Efree Escott, who isn't here, but a fairly new group. We just kicked off last year, but we've been building up content. We've been trying to invite speakers and just kind of have events with broader outreach to spread resources and spread knowledge about the tool. So hopefully we can keep that going. I've been in the architecture design field for about 9 years, give or take, and professionally practicing design computation for only about 2 years. Emphasis on the word professionally. So growing field, emerging field. Maybe you guys have even heard the word, or maybe not. I don't know. But yeah, that's my background.
So just a quick poll, a show of hands. How many people here are from the architecture department? Okay, so most people. Interiors? Anybody interiors? And what are the other departments that we have here tonight? AE? AE? You guys are AE? What specialty? Anything? Structural? Okay. Okay. And fifth year grad student level? One? Third or fourth year? Couple? Anybody like first, second? All right. Okay. So I think some of these lessons are going to be a little bit more applicable to people that have been around a little longer, just because if you've been working in an office, I know Drexel has a really great co-op program, and you've been working in Revit in an office environment, you'll understand some of these things a little bit better. Has anyone used it in an office environment? Couple. Okay, good. And does anybody have experience with Dynamo or Grasshopper already? A little bit of Grasshopper? Okay, great. So this will be a perfect level introduction for you guys. Okay. So what is Dynamo? Dynamo is an open source graphical programming tool for design. Okay? What does that mean? So to step back a little bit, let's just talk about what is programming. So programming is just the act of entering instructions for a computer to perform. All right? If we were to do that in plain English, it would be like, do this, then do that. Do this action that number of times. You have to be really specific with computers. Their computers are actually really dumb, and they do very simple actions, but they can do them super fast. Right? So what we're actually doing when we do programming is we're creating algorithms. An algorithm is just a set of instructions that lead to a predictable output. So this is an example of an algorithm for creating a paper crane. On the left side, we see a text algorithm that you could just read through that, and it would tell you exactly the steps to follow. On the right side, we see a graphical algorithm. Again, it just walks you through step by step for each one of those things. So in Dynamo, Dynamo is a graphical programming tool. It doesn't give you the little icons the same way that the paper crane one does, but allows you to interact with the program in a visual manner rather than dealing with just text like you would with a traditional programming language. So if we compare that graphic one to this bit of code, I think we can agree that this is a little bit easier to understand. So let's talk a little bit about the building blocks of Dynamo. So in our Dynamo interface, we have nodes. And nodes are basically just these little rectangles here. And each one does a very specific, simple job. Right? So the ones on the left here just give you an integer. The ones in the middle do a specific action, doing addition, multiplication, subtraction, or multiplication. And on the right side, you're just seeing what the result is of those. So the data flows in a Dynamo graph from left to right. We have our inputs and our most basic data on the left side, and everything just flows through to the right, and we get our outputs on the right side.
So this is kind of a first look at what a packaged script looks like, and I guess the proper terminology for what we're looking at is graph. Everybody calls it something different, and if you have experience with Grasshopper, which is a similar kind of platform on Rhino, you'll know that people use those terms interchangeably. But this is kind of what this is, and this is actually an example from something we've done at KieranTimberlake. So you see all the nodes that Dan just showed us. They're connected. Data, of course, flows left to right, and then we have some conventions up here that can give some hints to the user or to the author to let them know what the script is going to do, graph, whatever, what it's going to do, what each component is going to do, and then really even what each bundle of nodes is going to do, so that they can not just understand it, but also be able to modify it if necessary. So again, going back to those nodes, we see this little guy right here circled in red. So we zoom into him, and this is kind of what it looks like. Again, inputs on the left, inputs on the right. So what's really behind this node, though, and how does it know what to do? Behind this one specifically are, what is this, 3 times 6 or 8, so 18 or 24 pages of Python code. So that is, I mean, that's pretty heavy. But again, when you're working with the node, you don't really need to know what's happening underneath it all. You just need to be able to make use of the logic. And that's why Dynamo is so great, because it lets somebody else package all of their knowledge, algorithms, whatever, into a form which you can then very easily digest, consume, and digest, and use it for your own purpose. So when we kind of dissect the definition a little bit more, I think it's important to keep in mind that the Dynamo is very much operating in a BIM environment. So BIM meaning building information modeling. So unlike Grasshopper, which is tied to Rhino, we can make use of things that are kind of inherent to Revit, parameters, information. And so because of that, I really like to define Dynamo as a graphic programming platform for AEC. That's not to say that you can't use it for anything else, of course. I mean, all the basic functionality is there to create geometry, to create products, whatever you might want. But given Revit's inherent abilities for coordination and documentation, I think this is kind of the definition that makes the most sense. So to take it one step further, my kind of synthesis is that Dynamo is a graphic programming platform which extends Revit's building information modeling capabilities by allowing designers to create logic and processes which are built from the information inherent in the model, so the I in BIM. And then when we kind of look at the 3 categories of things that Dynamo does, this is the way at least I like to think about it. Extracts value, fosters flexibility, and informed building. And I see these kind of borrowed from other lectures on the subject, kind of common understanding. Specifically here, I'll cite Brian Ringley on this one. So when we talk about extracting value, there's a couple of things. We talk about data mining, taking information out of the model. So whether it's takeoffs, whether it's anything else, we can automate or delegate tasks to the computer, just like Dan showed with the algorithms. And we can combine processes in order to get the most out of our work. When we're talking about fostering flexibility, The majority of it is really just compensating for bad software or just making sure that the information we create in one software can be used by somebody else. So, and right now we have some engineering people, we have some architecture people, and you know that when you're out in the field, when you're out and working professionally, that those are typically separated into disciplines, and we need to make sure that the models talk to each other. Well, Dynamo is one tool that we have to foster that kind of interoperability. And then last but not least, we can inform our building process. We can analyze things for fabrication. We can prepare them for fabrication. We can QA, QC, all kinds of things, whether it's drawings, whether it's geometry. And we can really be better about descriptive or prescriptive geometries and be more precise about what we mean when we send those out to the field.
So the way that we've structured our lecture for the rest of the time is basically about giving some examples of Dynamo uses. We're generally going to try to go in each of these categories from a relatively simple example, something that you wouldn't have to be a power user to understand or to create, to more complex examples that really get into unlocking some of the really powerful things about Dynamo. So we're going to talk about some basic form generation, some analysis, developing patterns, task automation, and generative design. We have experience in probably all of these except for generative design. So we've just kind of structured it this way because this is what we've done. The world of Dynamo is huge, and there are a ton of resources online. So if you want to know about anything, you know, and most of our examples, again, are architecturally based, but there are a ton of engineering uses that generate and extract data from structural and mechanical systems. So to start off, we'll talk a little bit about form generation. This is an example that I worked on in my office that basically we use Dynamo to automate making some forms that were relatively simple, but in the aggregate fairly complex. So in this case, we're using it to create that baffled ceiling. So basically what we do here is we have a set of lines that define the boundary for it, and we select those lines from Revit, bring them into Dynamo, have them create a surface from that, divide that surface up using a bunch of intersecting planes, and then just put a wood baffle that follows the lines of those intersecting planes. So you can very quickly create something with thousands of elements just based on a couple of very simple building blocks.
All right, so this is actually kind of a little bit of a similar example. Let's see if I can get my link working. Let's make this go full screen. So the example here is we're trying to erase something very simple. We're trying to array mullions on a curtain wall. But what happens when we want to array those mullions in a pattern that's kind of atypical, or rather irregular? And as you kind of saw, in this case, it's kind of a gradient pattern. So this is a Dynamo script, and it even kind of features a little interface for somebody to enact that kind of geometry. And the way that they do it is by using this curve in the middle. So if you see that where the curve is low is basically where I pause it. Where the curve is low, the mullions are going to be dense, and where the curve is high, the mullions are going to be farther spaced out. So it doesn't look particularly attractive, doesn't look particularly computationally sexy, honestly. But when we think about those categories from before, think about extracting value for right now. I mean, 10, 15 years ago, you think about how you would do this if you were given this task. The reality is that you'd probably be sitting there and manually clicking the mullions in order to generate the designs. And for every option that you might want, you'd have to redo that, right? And you really wouldn't have a quick way to go back and forth between them or to edit them. And this just offers one way of doing that. Not just saving the man hours from kind of a purely business standpoint, but being able to translate that same time that you would have spent doing something repetitive and annoying, being able to translate it to doing something that you want to do, like spending time on design, on detailing, whatever the case may be. Did I go in order? Yes, I did. So our next example is a little bit more complex, and I'm glad I snuck this in here because I'm hoping that the engineers will enjoy this. So this is an example by ABT, I believe they're a structural engineering firm. And this example is about generating and documenting rebar. So these guys start, we can see on the left to right here, they start with a set of parameters which come in the form of Excel. And maybe these are specifications that a head engineer has passed down, or maybe this is calculation somebody else has performed. But the fact of the matter is that this rebar now needs to conform to those specs and find its way into the model. So step 2 here, what we do, or they do rather, is they read that Excel and they parse that information into Dynamo geometry. They use that Dynamo geometry to then drive and create Revit geometry. And then they also create their drawings in the same process. So again, thinking back to that process synergy, this is a pretty good example of it. So this is kind of what it looks like. On the left, we see the graph, fairly complex, fairly dense. We can see there's a lot of things going on, even though the form may not be terribly complex, maybe a stadium or something like that. But being able to parse the data and map it correctly to the correct elements, that's kind of what's happening on the left. And on the right is a visualization of the rebar that it's generating. And for most people, I think that's definitely good enough. I mean, you've already saved so much time, and you have the ability to go back and QA, QC the process at whatever point you want, because the graph kind of gives you this history of logic. But that's not all you get. The great thing is that you also make progress towards the deliverable, right? Unfortunately for right now, our deliverable still remains a piece of paper or a PDF. So we still have to keep our thoughts on this, but the good thing is that tools like Dynamo and just other applications of computational design can create a little bit of a shortcut to that deliverable.
And so this is actually, on the very complex end, this is a package that was created called DynaShape that actually shows you the real power of Dynamo in that they built an entire physics engine inside of this. Oops, if we play this YouTube link. So they've actually made this so that it creates an entire field and allows live interaction with all those points that then push and pull each other and create some really dynamic, catenary shapes, inflatable shapes, things like that. It allows you to, do some wind simulation. It has the possibilities for building these things in Dynamo are practically limitless. And we can use these to create, all kinds of building shapes. Okay. So analysis. So we know that in our BIM models, there's tons of data associated with everything, but sometimes it's a little hard to visualize that to be able to quickly synthesize an idea. So this is an example from my office in which we have an existing building that, because of a lot of existing conditions, low beams, HVAC that we couldn't really get around, we had to have a lot of different ceiling heights. And to be able to, in order to be able to document all of our conditions to see where we need details for things, if we just looked at this in a reflected ceiling plan, we could look at the tags for all of the individual heights, but we'd have to keep that in memory. So what this one is actually just taking all the ceiling heights and having Dynamo color code everything based on the height. So mapping all these to a gradient. So you can see the red ceilings in the very center are very low, up to the blue ceilings at the highest locations. So it's just a simple way of being able to visualize some data that's already in there.
All right, then we have a couple more kind of in the middle, intermediate examples, I'll call them. So this is an example by Dieter Vermeulen regarding fire exit safety evaluation. So for those of you that have put together some life safety plans or egress plans over the course of your careers, you know that this, what we're seeing at the bottom, is kind of what they look like. You basically need to make sure that every unit, in this case it's a residential building, you need to make sure that every unit has an allowable distance of egress to the nearest fire exit. And again, those are calculations which you could do manually, and it takes some time, and then every time the design changes, you redo the calculations, you redo it, you redo it. But it really makes more sense to capture that intelligence into a computational format, in this case a graph. And that's exactly what he's done. So this is what the script looks like, and the nice thing about Dynamo is that you can also get a kind of in-screen preview of the geometry. You don't have to necessarily always be working in the Revit environment. You can preview it directly in Dynamo as well. And here, you not only get the visualization of the calculated paths, But then again, making progress towards your actual deliverable, Dynamo is also putting those lines on drawings, on sheets for you with graphical styles that you have selected so that your drawings are already done for you when your design is changed. Another very simple but pretty interesting example, in my opinion, is evaluating head height clearances. So again, those of you that have worked at least once and worked on a staircase, you know that there's, especially in monumental stairs, not so much stair cores, but in monumental stairs, we have to be sure that, I forget what it is in the States, honestly, but you have to have a certain clearance above your head so you don't injure yourself. And again, you could check this every time. You could export sections and you could just measure things, or you could just embed the intelligence once in a graph where you can just select the stair, select the floor slab, and just get some lines. Green if the head heights at every step are allowable, red if the head heights at the step are too small. And again, lets you visualize that very quickly, make design decisions, and move on. So the next analysis example is definitely the heaviest one. So this is a project by KieranTimberlake, NYU. Don't know if you're familiar with this project. It's at 181 Mercer. It's an absolutely massive 735,000 square foot multi-use building. It's essentially an entire campus on one block of New York. And the rendering here on the right, I mean, just even glancing at it right now, you can see that there's a lot going on in the facades. We have different conditions on the mass that's lower. We have different conditions on the mass that's higher. And in addition to that, we have all these unique, funny conditions that would be happening in all of these stair-step locations, right? And of course, the design team has to account for all of that. And the question is, how do they do it? It's a big question. It's a big question because I think the last time I ran a check on this model, there were, I want to say about 500 unique panels. And that's just unique. In terms of panel instances, there were thousands. So this project being in contract administration right now, or maybe you know it as construction administration, this is especially critical because what's happening is the people on the field are sending us submittals that we have to review, and we have to verify the amount and the type of curtain panels and mullions that they're going to purchase. And we have to be very sure about that before they make that purchase. Otherwise, we got a real big problem, and it's on us. So again, hundreds of unique panels, thousands of actual panels, and how do we do it? So we first did a very quick proof of concept with Dynamo, and is actually showcasing a couple of things that I like. So in the newer versions of Dynamo, you get this very nice interface here. It's called the Dynamo Player. So what that allows you to do is, if somebody like me that kind of knows what they're doing has put together a graph or a script, they can kind of also package it up so that somebody else in their office that might not know Dynamo but might want to use it can use that script. And the Dynamo Player is kind of like a very, very easy interface to distribute that kind of stuff. So this is what we're seeing on the right. It's essentially the output from the script. So what this is doing is, first it's finding, let's start here, actually start a little bit lower. First it's finding all of the unique panels in the selection. Then it is testing for neighbor conditions. In this case, it's only testing for one panel because it's a proof of concept. It gets you those neighboring conditions. And then it also gives you a list. Sorry if you guys can't see that, it might be a little bit small. Gives you a list of suggested details. So again, for those of you that have done some detailing, specifically exterior detailing, you know that every single unique condition, unique joint has to be captured. If two materials are coming together for the first time, you need to document that in your set. And that's quite easy to kind of keep track of when you have a small building, small amount of unique intersections, but, well, you get the idea. So we also scaled that up, and this is actually that same test run on the tower. And again, unique panels, number of suggested details, and we actually took it one step further. And because Dynamo allows us to make use of that information inherent in the BIM model, we were also able to not just query the geometry of these panels, we're also able to extract information from the sheets, from the drawing sheets in the model, extract information from the drawings that are on those sheets, and then determine a likelihood that somebody's already drawn the detail, right? And again, that's quite simple to manage when you have a small project and not so many unique panels, but when, let's see, how big is the team? The team is probably around 30 plus people. It's almost impossible to know who has drawn what. So this is just one way of QAing that. And the beautiful part about this is, you can even see, that logic is absent from this version, but it's in this version. Great thing about Dynamo is its modular nature, its nodes, it just lets you copy paste. It lets you kind of Frankenstein things together, and it lets you evolve your logic. So you don't have to start from scratch every single time, which is a huge help.
So Dynamo is a great tool to automate pattern development. And it allows you basically just to take the building blocks and the logic of your pattern and apply that and make changes very quickly and iterate over different conditions. So this is an example that I worked on where we had a building with a very simple massing, just kind of a rounded corner box with a bulge in the middle, and just wanted to wrap curtain wall around the entire thing. And so we wanted to make the facade interesting basically by doing randomization. And rather than trying to do it all manually where someone goes in and clicks a panel and says, I want this to be type A, type B, type C, we did this in Dynamo. So we did this by basically, you can see in these colored panels at the top, finding all the different permutations of the 4 different major panel types, and then shuffling all those different permutations and cycling them around the entire building. And then if we want to change any of the ratios, we just have to change one little setting and it's able to adapt everything. This script also then applied the materials to the facade, so we were able to control for different glass types, and actually be able to see some what would happen if we changed the ratios between the different glass types without having to manually recreate everything. So this is just an animation that I made that cycles through different ratios of the 3 different glass types, so we can see just from a very basic level what do we think the correct ratio of all these materials is.
All right. And hopefully, I think we'll definitely have time to maybe show you guys a live demo of this one. This is very similar formalistically to this one, but functions differently. Both function in Dynamo, but different ways, which again is a neat thing about Dynamo. So the one we're looking at right now, and you might check out the live demo later, is actually almost entirely written in Python. So not necessarily making use of any of the Dynamo nodes, but making use of the programming language integrations that exist within the software. And why would you want to do this? Well, the great thing is that if you do get comfortable with Python or with some other language, you can set something up like this in Dynamo, in Python, or whatever you want, and then you can package all of that logic back into a node, just like we saw at the beginning of the slide, and then you can upload that to the Dynamo package manager, and then anybody else can download that and make use of that. So it's a very easy way to share your knowledge, share your scripts, share your tools with other people that might not have the know-how of creating them, but still might want access to that same information. And actually, yeah, this is what it looks like. As you can see, it's visually pretty different than some of the past ones we saw. Definitely a lot more text. Definitely a lot more text, a little bit less spaghetti, but the result is more or less the same. And the great part about this too is that at first glance it looks pretty intimidating, but one of the definitions I always like to use for Dynamo is that it's textual programming masquerading as visual programming. And the reason being is that it also has a very, very nice feature, which I actually haven't seen any other visual programming software have, which is you can select a bundle of nodes. Let's say you select these guys, and you can basically right-click them and say, turn it into code. And if I can zoom in here, nobody can zoom in here. All right, that's minute to 2 with Google Slides. But so you can very quickly turn something like the purple blob into something that looks exactly like that blue blob that we're seeing right here. So it goes from node to code, and you have to do pretty much nothing besides read the code. And if you want to teach yourself that kind of textual style, you can start to reverse engineer it, dissect it, and make the most of it, really. And then, again, I said intimidating, but in reality, it's really not that intimidating, I think, especially if you're orderly and clear about the way you're doing things. So I don't know if anybody in the room has existing Python experience. I'm assuming that for most of you, this is course you're seeing of it. But I just want to throw it out and show exactly how non-complex it is. So, and this is pretty much the entirety of the logic that is used to generate these custom random brick arrangements and courses. So, basically, the first part of any Dynamo script is a bunch of givens. You just need to define some variables, define some inputs. You need to import some libraries and tell it what to do. The second thing is you set up some containers. In my case, it's typically a list. Basically, just any list you might want to fill with data that you're going to want to pull out later. The next step is you just parse the rules. So however you put in your input, you just need to be able to deconstruct that. And there's a number of ways. I think we saw in some of the previous ones, there's sliders, there's even some custom interfaces. There's a ton of different ways to parse the user's rules or the user's input. This is just one of them, and it doesn't even have to be in code. And then you have your main logic, which is pretty much 1, 2, 3, about 8 lines of code. And all it says is that take a line, while the horizontal distance traversed is less than the total length of that line, keep going, and basically append the user's input rules one by one to that container. And then when the distance is equal to 0, when the distance is equal, you start from 0, but you go 1 up. So what does that mean? We're traversing this line, and when it reaches 0, right, we start from 0, but we just start the next course. And that's, I mean, you guys know how Brickball is constructed. It's just human logic translated into code. Same thing. All right. I think this one is mine as well. So this is the uncooperative GIF of sheets that won't renumber, I think. Or no, sorry, this is the, yeah. All right, no, not this one. There we go. Okay. So again, those of you that have put together some drawing sheets, especially in Revit, you know that when you need to add drawings, remove drawings, or just kind of reconfigure the sheet, that it can get very annoying very quickly, because as soon as you try to change the number of a single detail, Revit says, no, you can't do that. You have another detail on the sheet with that number already. And you say, okay, well, all right, I'll change that one to 2x, and then I'll change mine to 3, and then I'll change that one back to 1, and then I'll change mine back to 2. And that's really annoying. I mean, besides being annoying, it just wastes a ton of your time. Again, time that you can spend on a number of other things that are going to improve your well-being, your life, and frankly, the well-being of the project and the life of the people around you. So this is a very simple Dynamo script, which basically just lets you draw a line. You can't really see it, but that's what I was doing. There we go. That's the line. And the order that you've drawn the line in is basically the order that Dynamo will go through and renumber those drawings. Lots of tools exist to do the same thing. This is just a Dynamo way to do it. I think it works just fine. Okay. Let's go back to, whoops. Presentation. So this is the uncooperative GIF. Unfortunately, it's not playing, but this was an automatic sheet list creation. So again, those of you that have worked and had the responsibility of collating a set at a major milestone, you know that you are receiving drawings from consultants, structural, MEP, landscape, so on and so forth, and you need to combine them with architectural drawings, and you need to combine into one PDF that gets delivered to the client, and everybody's happy. Well, the thing, though, is that before you do that, you have to create a table of contents of sorts. Your set has to, at the very onset, delineate what's going to be contained within it. And consultants typically send you their drawing lists about a week before, but, well, things happen, people make changes, and that is very rarely the actual drawing list that happens in the end. So a lot of times what happens is we just get these dumps of PDFs, just folders full of PDFs, and previously we've had to go in there and just, okay, type it all out in Excel, manual data entry style, and that's how we get our table of contents. And the unfortunate animation that won't show right now is a Dynamo graph that lets you select a folder or a bunch of folders. It will loop through the drawings, and based on typical architectural convention, it will create you an Excel of numbers, names. It will also generate those lists for you directly in Revit if you want to schedule them as dummy sheets or something like that.
So this is an example of another type of task automation where this is actually for doing model audits. So if you've been working in an office, you know that over time your models just get kind of full of junk, and depending on how experienced your users are, they may have a ton of bad modeling practices. So this is an example that someone created and posted for everyone to use online. That basically just looks through your entire model and finds a bunch of different things. How many in-place families you have, how many groups you have, how many text styles that don't match your standards you have, and basically looks through your entire file, combs through all those things, and outputs a Excel file that just tells you what all of those things are. So you can take data that's in your model and extract it out and have it in a more usable form. You could do that you could also do that manually just by looking through everything, but by having a script do it for you, you don't have to spend the time of doing all those individual little mundane tasks. So let me get into generative design. Like I said, Peter and I don't have as much experience with this directly, but so the examples here from a lecture that some women from Autodesk gave to the Philadelphia Dynamo user group a few months ago. It really shows some amazing examples. I encourage you to go on the PDOG website to look these up. But basically what they were doing is coming up with a bunch of different categories of positive aspects of a floor plan, of an office layout. You know, access to daylight, low visual distraction, views to the outside, etc. Creating those into code, and then basically allowing the program to flip through those different things and try different arrangements in order to generate an actual floor plan. So in this case, they were also using, they would put in their program so that they have all of the different adjacencies and sizes for everything. And they'd output a floor plan, and they could actually output 100 different floor plans in various configurations that all optimally meet their criteria from early on. And last but not least, a little bit of fun stuff. As Peter said, Dynamo directly integrates with Revit and is primarily built around interacting with Revit, but you don't have to use it just with Revit. You can use it just as an interesting tool. So in this case, I saw an example of someone that had created an algorithm for taking some paintings and breaking them down into little blocks and then using those blocks to extract the color from the painting and recreate it as this sort of digital version of the painting. And I thought, hey, I'm learning some scripting. I could try to do this. So I hacked my way through it for a long time, trying to figure out how do I take a rectangle and divide it in two. You'd be surprised how long it takes to learn how to divide a rectangle in two. And basically, for each rectangle, you put in an input image, and it would break that overall image down into two rectangles, and say how much contrast is there. If this contrast is over a certain threshold, then divide this again, and keep dividing it until the contrast is within any individual rectangle is low enough that it meets this certain threshold. So this is kind of a view of all the different rectangles, and this is some of the output from that. So part of what made me inspired to do this was just thinking that, like, wow, being able to divide things up would be a great way to create things like stone or brick patterns. But without having a specific building use that I wanted to do, I decided that I was just going to put in a picture of my daughter to create this. So this actually is an image of my daughter rendered in Dynamo.
So we will try and hit up the live demos, but prior to the end of the official presentation, I do want to leave you guys with some resources in case you're curious about this stuff. So the first resource is, of course, our website, the Philadelphia Dynamo User Group website, which I'm going to click on and show you guys right now. So this is where we have all the content for all the meetings, and actually eventually we will upload the content for this one here as well. What we do is, let me pick a especially interesting one. What we do is we have the video recording, which you guys will also have right now. We include any source files that were given as part of the presentation. The original presentations, of course, credits / just links to the people that presented, or their websites or their resources, and of course just the actual slides even embedded here as well. So currently building up our content. We have a number of items, but definitely growing. Take a small side step here just to show you one other unique application of Dynamo. So one of our last speaker actually made his engagement ring. He designed his engagement ring using Dynamo, and then he produced it. I forget the contractor that he used, but that's the finished product right there. So definitely many uses, even though it's primarily BIM integrated, but sky's the limit, really. So anyway, this is the meetings. We also keep the schedule up to date. If you want to attend some meetings, they're absolutely public and open. We are currently rotating venues around the city where we've been visiting different architecture offices. I believe we had a session at Ballinger, right? We've done a session at KieranTimberlake, done a session at several others. So it's not just a good way to learn about Dynamo, it's also a good way to get exposed to industry peers, see what they're working on, see what their office looks like, what their environment looks like, and just get to know people. So in addition to that, I want to show you guys some other things. And again, this will be uploaded to the website, so no need to furiously jot all this down. Huge resource right here. It comes directly from Autodesk, the makers of Dynamo. So the one on the left is the Dynamo primer, and it's kind of exactly what it sounds like. You see on the left, they've really broken out topics and subtopics, and this is really the basics. I mean, primer kind of implies that, but a lot of the stuff that we covered in terms of nodes and basic operations is in here in much greater detail. So if you have any questions, I definitely encourage you guys to jump in there. And in this presentation, everything is linked, so you should be able to just click and go right there. Other thing is the Dynamo Dictionary. Okay, yeah, it is linked. The Dynamo Dictionary lets you very quickly, well, it's not loading right now, but it lets you very quickly type something into the search and see what comes up. So what I do a lot of the times is, because there's no way I can just have every node in my head, I just come here or I go directly to the Dynamo interface and I start typing things that I might want to know. Maybe I want to work with work sets. I don't know what's available. But as soon as I type it in, the search fails me, of course. All right, let's go back to Element. Let's try one other one. Okay. So, good resource for exploration. And they also have a very good set of videos. So on the left, we have some introductory videos. On the right, they have advanced videos. And I found these to be very, very useful because they take you through not just the basics, but they properly take you through the basics. They really don't miss any steps. The fundamentals are covered. So if you are interested in having a great foundation for this type of work, which can not only be applied to Dynamo, but you can take that same intellectual framework and apply it to a Grasshopper, or maybe you want to do some more advanced coding, I think that's a great place to start because it'll teach you about things like variables, lists, loops, basic functions of programs or algorithms or computational design in general. And the advanced videos get a little bit more into the weeds. Let me just give you a couple of examples. So editing elements in Dynamo, structural framing, editing with formulas, that kind of stuff. Whereas the basic stuff is list management, data management, things like that. Then we have a couple of more pages here of very, very good resources in terms of blogs. The Dynamo forum is huge. You basically post a question there and it's going to get answered within 30 minutes flat, more or less. And also just not even as posting questions, just searching it will yield so many things. For the most part, any question that you might have is probably the answer in the Dynamo forum. A couple of other really great blogs, again, linked, so check those out. San Francisco Dynamo User Group is a great resource. They've been a user group that have been around for a very long time, so they have a richer library of content. A couple more blogs, and of course, one of the biggest resources as well, coming from Autodesk themselves again, is Autodesk University. Not sure if you're familiar with this site, but I would definitely encourage you to check it out. It's basically an aggregator for talks or presentations that were given at Autodesk University, which is a very large conference held every year for industry trade leaders. And the cool thing is you can search here by type of software. So maybe if you want to learn about Dynamo, you just filter by Dynamo, and then it'll populate you with talks, and you can kind of scan through them. And I mean, there's really some great stuff in here, and people really go to great lengths to make these presentations great because, again, it's a national audience. So the fact that it's available for free, both the source files and the video recordings, is a really big resource. I encourage everybody to take a look at that. And I do believe that is it until...
Yeah. So I guess we have some live demos we can do of just some really basic functions, but I want to open it up for any questions anyone has. We're getting to that. So, yeah.
Do you need to master Python before using Dynamo?
No, not at all. It helps to, I will say that understanding some programming languages helps you understand some of the logic and some things like data, but you do not need to have any experience in any programming language at all. If you go to the Dynamo Primer, it will walk you through all the basic concepts that you need to actually apply to programming across the board and give you all the basic tools that you need to start working directly in Dynamo. And it'll work you through basic data, how to create forms, how to automate tasks, how to start bringing things directly into Revit. It'll go through all of it. Yeah.
How Dynamo works within the hierarchy of an office. Like if there tends to be one person who does all the Dynamo stuff in order to make Revit easier for everyone. I think it's the other way. Like, are people really hesitant to use Dynamo since some people are really hesitant with Revit?
It's, I would say it's probably extremely variable. So in my office, I'm probably the only person, we have about 200 people, I'm probably the only person that's actively doing anything in it. But I'm trying to encourage through a bunch of avenues more of these by building up a library of really basic scripts. Some offices, if they, depending on people's backgrounds, they will, have tons of different people that grab it and go. It really just kind of depends on the people in the office. You are able to, with things like the Dynamo Player and locating things on a network, you're able to share everything that you did with your office. So, it doesn't ever just you working in a vacuum. You can start to create tools that make everyone's job easier pretty quickly.
Yeah, and I'll add my own little layer on this since I don't shut up about this kind of stuff at work. There's a lot of ways you can really think about it, and the great thing about Dynamo is, as we kind of mentioned, there's the possibility for reuse and modularity. So the term that I use, hold back the gasps, is a systematic reappropriation of design agency. And I don't want to go into the weeds of what that means right now, but I mean, when you think about it, some of the packages that we showed before, for example, you can make use of, it doesn't have to be an architect's knowledge, it can be an engineer's knowledge. And that's at a broad scale. At a firm scale, which is what you're asking, the question is still interesting though, because there's hierarchy of knowledge and experience in the firm. So a lot of times even making that point of communication is quite difficult. So in terms of these kind of workflows, these are the ways that we at least kind of think about them. Pretty much stage one, no matter what you do, almost I want to say, is top down, and that's going to be the one guy, whether it's me, whether it's Dan, doing it for everybody else. But my kind of thinking, and our thinking at least at KT, is that that's a stage one, and we should really aim to be a little bit more ambitious. So stage two is more of a hybrid workflow where there's a distribution from somebody like me to a group of not power users, but still more competent users, and then there can be this back and forth between all of us, and then they can kind of distribute that to their teams or to the people that they're working with. Yeah, and of course, then there is the ultimate, that's kind of like the last stage is completely distributed, where somebody like me makes a framework, just a skeleton of an idea, and then all of your users are just knowledgeable enough to be able to take that framework, run with it, reappropriate it however they might want to whatever task or project or inquiry they might want, and do their own thing. So anyway, long-winded way of saying I think it's definitely a process, but I think for most offices right now, no matter what, it is this one, unless you are explicitly specializing in a kind of computational design workflow. So the firms like, a proving ground or a Woods Bagot might not necessarily be the top down. They might be a little bit closer to hybrid. I don't know that anybody's here yet, but Towards distributed? I would like to. I mean, right now, I really don't want to impart my preachings on you guys, so shut me up. But yeah.
I think that, because of the nature of the architectural, engineering, construction practice in which, our projects aren't fast. They take a long time, and so therefore expertise takes a long time to build up. That means that our industry in general is slow to respond to new technologies and new sort of ideas like this. I think it will take a long time to get a majority of offices to be using some tools like this. But the great thing about it is that these tools are easily available. And so anyone that wants to get into it can get into it. And you can make it, you don't have to have a design environment that is built around making crazy shapes that you can only make in a scripting, with the scripting tools. You can be doing completely conventional buildings and still get use out of all of this stuff. So I think that over time, more and more people will build up, and it'll become more of like the fact that, even still today, not everyone uses computers to draw things. We still have some people that hand draft projects, and they still do just fine work. In the same mode, not everyone will ever make it to this, but it definitely is on the rise.
Yeah, and I'll say that most, I think, are trending towards this middle one. We already kind of are seeing firms, for example, post job openings, architectural firms post job openings for software developers or for computational designers. So I think that's a step towards the first one. But to get to here, I mean, that's really so far down the road that it's more of kind of like an intellectual construct at this point. Like, it's so far off that I can't really even picture it.
We're asking all of you to start learning it so that we can get to that middle section.
That's producing floor plans based on something that like a client could input, right? So it's like a really kind of interesting thought about.
It's an interesting idea.
What could be generated without us?
Yeah, I used to have a little bit more trepidation about that, and then I was actually listening to the news in the last few years, and they would talk about how they were creating algorithms on Facebook or whatever that can categorize your photos and do all kinds of things. And what they didn't, this is kind of a negative example, but what they didn't realize was that when they started off with their data set, there was an inherent bias in it. There was, anti-women and there was racist things that were in their data set they didn't realize. What that actually gets to the point of, though, is that the designer still creates the system in which the product is created. So once you've created one system, you've only just made one system. Yeah, you could apply that to every building, but I don't think we'd ever want to have all those buildings be the same. The designer still has the control of creating the inputs and creating the structure in which those things are evaluated.
Yeah, and don't want to try and blow your guys' minds way too much, but a lot of the code that we've seen, like that we just saw, and the words that we used, algorithmic, that implies a very specific and very linear kind of translation of logic into code. What's interesting is that we're seeing now is that as architecture is adopting some of these very basic kind of algorithmic linear functional programming constructs, at the same time other industries are making big moves in things like AI, for lack of a better word. And that is a fundamentally very different concept, because in those applications, you're not writing a linear algorithm. You're actually writing code which writes code. If that's kind of hard to fathom, but it's just interesting the disconnect that, as Dan was pointing out, that we kind of lag behind industry. So while they're making this progress, we're making some progress, but yeah, the disconnect is still there. So I'm curious what we're going to do when we hit our wall with algorithmic programming.
Maybe as a segue to your demo, I'm wondering, so from students, like a lot of the examples are examples of practice, and there's obviously kind of a lot of time spent in that first square, like setting this up to make other things efficient, right? I'm wondering from the student's perspective, how, like, given the time frame of a school project and the office of one usually exists within a school project, like, how do you see that efficiency, like, working for an academic project? Do you see Dynamo being able to kind of fit in that realm, or in certain capacities, like their specific projects? It's a difficult case-by-case question, and I'm curious, like, if you see that as a possibility for students.
Yeah, I think that it's probably a case where you have to start off with the basics. And so I can't think, it's been so long since I've been a student, I can't think of a particularly great example of what I'd be doing. But whenever I started learning these things, I started off with the most basic operations that I could figure out. I knew that maybe I wanted to do this randomization, but I just had to figure out, okay, how do I have Revit change a curtain wall panel from one thing to another one? And then as I built that into more and more complex things, I was able to create bigger and bigger tools and got more comfortable just throwing things together. So I think from especially a student perspective, being able to just start off with something that is mundane or simple or whatever, that just lets you get your feet into it, is kind of, you have to start there, and then over time you'll learn what, how to make those things work and how it can start to fit into your process. I think, as you start to learn any type of programming, whether it's Python or Dynamo or anything else, it starts to affect the way that you think about things, because you start to think about them as a series of steps, and as like, this isn't just an amorphous blob of concepts, it's actually a bunch of discrete things that I can break down. And so as you start to deal with problems in that manner, you can envision the possibilities, and you already have the tools to make those things happen. So on a basic level, you could start off just making a simple shape and having it, play with the sliders and have it, make it longer or taller or anything, and just go on from there.
Yeah, and one thing I'll add is, kind of my perspective is, let the questions that you want to answer drive your use of Dynamo or any other tool. It's kind of how we at KieranTimberlake approach a lot of the questions, but I don't have the PDUG website easily open. But maybe think about a question that you might want to answer. Maybe you want to investigate solar shading. So once you have that question, I think it makes sense to see if Dynamo is the right tool. And you can do any of the number of things that we kind of looked at earlier. You can search. You can look to see if there's existing packages that do the same kind of stuff. But then with a very critical and purposeful eye towards answering that question, I think it makes a lot of sense to build your Dynamo work around that. And then, once you do a couple one of those, or however many, you do get more comfortable, and you can modify and apply as you see fit.
Yes. So we're right about at our time.